Welcome to your first week of text-based programming. Previously, we've only done block-based programming, where we drag and drop programming structures in order to avoid having to worry about things like syntax. This week, we're going to dive into actual text-based programming and all the syntax and typing that comes along with it. So all of these tutorials will be using Trinket. It's easy to get set up, so that's why I'm using it, because most of you will also elect to use it. However, if you want to use your own Python IDE, or otherwise known as an integrated development environment or a text editor, I will have separate videos instructing you on how to get those set up. The benefit to those is that you can run them entirely offline, so you don't need an internet connection in order to use those tools, whereas with Trinket, you do need an internet connection. So we're going to use the Python 3 trinkets for all of our lessons. So go to your drop-down, New Trinket, Python 3. While Python 2 is still used today, it is aging and it will be completely phased out in 2020. So Python 3 is the way to go if you're learning Python for the first time. So we're going to start off with the classic hello world. So in Python, we want to use a print statement to print out hello world to the console. In Trinket, we will do all of our typing on this side of the screen, and our output will be on this side. So to do hello world, we're going to do print, and then parentheses, single quotations, hello world, and click run. And it prints it out for us right over here. So you'll notice that as I was typing, it came up with some suggestions. So that's one of the benefits for using what's called an IDE, or Integrated Development Environment. Trinket is a very simple IDE that's hosted online, and there are very, very powerful IDEs out there like PyCharm that do a lot for you. An IDE will prompt you for suggested words, like here we started typing PRI, so it's pretty sure that we want to do a print statement. So if you just press enter, it will complete that word for you. If you type in 1/2 of a parentheses, like here I only typed in the open parentheses, it completed the other half for me without having to go and me type the other half myself. Similarly, if I type a quotation, then it's going to put in both halves of that quote for me, so I don't have to close my quote at the end. Those are some of the niceties that an IDE brings along with it, as opposed to working with a text editor that's not meant to be used with programming. So for here, I have print hello world and then print hello. In our block-based programming, we've referred to text very loosely, but today we're going to get into a little bit more of the details and what's called a string. So instead of just putting hello world in quotations, let's make a variable. We'll call it hello var. In Python, variables are often have words separated by underscores. This is called snake case, and it's the preferred method of naming variables in Python. All programming languages have their own styles that are typical for that language. In Python, using snake case for variables is typical, so you will see me name variables with these underscores and in all lowercase because of that reason. So let's say hello var is equal to single quotations hello world. I've just created a variable and I've assigned it the value, the string hello world. Now I can use my print function again, print, open quotations, and this time instead of typing the quotes in it and then hello world in the quotes, I can just type hello var. And you'll notice that it's again prompting me because it knows that I have created this variable here. So it's giving me some help to know what variables I've created already. So we can just autocomplete that by hitting enter. And if you run it, you can see that we've done the exact same thing. It's printed out what's contained within this hello var variable, which is the string hello world. In Python, we call text strings. And with strings, there are a lot of interesting things you can do with them that we'll get to later in this semester, particularly how strings are implemented in the Python language. Strings are not in every languages. Some languages, like C, only have the concept of characters, and you do everything with arrays of characters. However, Python does have a data type called string, which has all sorts of built-in cool functions that we can do with it. So let's say, for example, that we wanted to figure out the length of this string. We could do hello var length equals len, and that's a function, open parentheses, hello var. And then after hello var, let's type, we want to print my string length, comma, hello var length. So you'll notice that it printed out the first one, hello var, here, and then it did something funny. It printed out two different things. So in Python, if you have a print statement and you have comma separated values inside these parentheses, it will print them all. So you'll notice that I had a leading string, my string length, and then a space still inside there, and then comma, hello var length. So it read in the length of my hello var variable, and then it used that in this print statement. So the resulting printout was my string length 12. Hello world has 12 characters in it. Another cool thing about strings in Python is that you can access string characters with the index. So if I wanted to get, say, the first character in this string, I could do print hello var, and then in this time square brackets 0, it will print out H, which is our first character. So I'll just write the first character, comma, hello var in square bracket 0 is going to print out H. So you can access different characters in a string using the index, just like we talked about in lists in Module 2 when we were still in block-based programming. In fact, you can think of a string as just being a list of characters that in Python has some nice functions that come along with it. Strings in Python can be denoted both with single quotes and double quotes. You'll notice that I've used single quotes here because that is the typical Python style. However, you could do print, this is using double quotes, just fine, and it will interpret it as a string and treat it as a string because it is still a string. And there are situations where you would want to use one or the other. Generally, if you don't have a reason not to, you want to use single quotes. However, I want you to look at two different scenarios. So let's say I had two strings. My first string, I'm going to use single quotes. I'm going to say, it's raining outside. And my second string, I'm going to use double quotes. I'm going to say, it's raining outside. If I print first string and I print second string, we're going to have an issue. We have a syntax error. So in the first case, I've used single quotes in order to enclose this string. So when I had this apostrophe in the its, it caused a problem. It thought I was closing that string. So when I tried to run it, it threw what's called a syntax error. I have something wrong with how I type something. However, if I comment this out, that second string prints just fine, because if I have the double quotes, it knows that the single quote inside is not meant to end the string. It's just another character inside the string. However, we can get around this by doing what's called escaping the character. So we can escape the single quote by putting a backslash in front of it. So now when we run this, both print just fine. So it's a convenience that you can use the double quotes and not have to escape a single quote inside a string. But if you always want to use single quotes, that's just fine. All you have to do is escape any characters that are inside the string. One last thing I want to show you before we move on to numbers is how you do a new line. So I'm going to do a 2-line string. And I just want to emphasize that what I'm naming these things doesn't really matter. I could name it global snitch or something like that if I wanted to, except for that wouldn't be very descriptive. When you write your variable names, you want them to be descriptive about what they do. So that makes your code much more readable for both you and for anybody else who's reading that code. And in the case of this class, that's likely to be me or the other teachers. So we would very much appreciate it if you had descriptively named variables. So I'm going to create a string that prints out in 2 lines. So I'm going to say, it's raining today, and I'm going to use that escape quote just for fun. Oops. And then on another line, I want to say, but tomorrow it'll be sunny. So if I did just an enter and then put, but tomorrow it will be sunny, then I'm going to run into a syntax error because it doesn't think that I've actually ended this string. It doesn't understand that this is the same string on 2 lines. Python is sensitive to both white space and enters. So we need to do what's called an escape. We could put this into 2 different variables as we've done before and then print them out separately, or we could put what's called a new line character in it. So a new line character is \n. It looks just like this. So now if I do print 2-line string, it will print it out onto 2 lines. It'll go, it's raining today. It'll find this new line character. It'll go to a new line in the output, and then, but tomorrow it will be sunny. So that was a lot of information about strings all at once. But you'll get plenty of practice with strings. We use them all the time in programming. Now we're going to talk about numbers in Python, in particular 2 different types of numbers, one called an integer and one called a float. So an integer is exactly what it is in math. It's like 1, 2, 3, so on and so forth, without any sort of decimal on it. A float you can think of as having a decimal attached to it. We'll talk a lot more in future classes about exactly what it means to do floating point number arithmetic and stuff like round off error, because computers can't actually store the majority of numbers exactly. They store them as approximations, and that can lead to some issues when you're doing floating point arithmetic. But for the most part, it will be fine. So the first one is called an integer. So I'm going to make a variable, my int is equal to 2. So you can print integers just like you can print strings. So this prints out 2. If I had a second int, my second int equal to 5, then I can also print their sum directly in the print statement, plus my second int. And we get 7. So just like in the blocks, we can use plus, minus, multiplication, and division. So we have plus, I'll just copy and paste these, plus, minus, multiplication, and division. Division is denoted with a /, and multiplication is denoted with an asterisk, which is Shift 8 on your keyboard. So you can print those out, and you see we have 7, -3, 10, and 0.4. So I want you to notice that on all the other one of these, we do not have any sort of decimal. We've done an arithmetic operation that just led to another integer. However, Python is clever. A lot of languages, by default, if you have an int divided by an int, it will default to integer division. And in fact, in Python 2, that's the the default case. However, in Python 3, division of two integers goes to a float automatically, so you don't have to worry about that. We also talked about two other operators. We talked about modulo and integer division. So for integer division, we're going to do my second int and then 2 forward slashes my int. In this case, we're doing 5 integer division by 2. So if you recall from the operations video in the block-based programming, integer division divides and then cuts off all of the extras, so without any sort of remainder. And then there's also, just going to copy and paste this, there's also the modulo operator, which is %. So I'm just going to label these really quick so that we can tell what's going on. Okay, I've labeled, and probably after some movie magic, I'm going to run it. Okay, so 5 plus 2 is 7. In this case, we have 2 minus 5 is -3. 2 times 10 is 10. 2 divided by 4 is 0.4. And I've switched the order on these second two just to make it easier to see the integer division and the modulo. So I'm actually going to put it in what's called a comment. So any line that you begin with a hash mark is not read by the Python interpreter. That's just for any humans reading your program to tell what's going on. I'm just going to say I've switched the orders. So now if I run it, that comment, I've switched the orders, is not going to do anything, but it's there to notify any humans reading your code of what's happened. So this is integer, how integers interact with each other. However, I want you to see what happens if I do something as simple as putting a 0.0 on the end of one of these ints. Now you'll notice that all of the additions, subtractions, and multiplications, and integer divisions, and modulos all have 0.0s on them as well. They've become floats. Now, for some things this doesn't matter, but for other things like accessing indexes in lists and stuff like that, those require integers. So there's an easy way to take a float and turn it into an int. So I'm let's delete this. If I have my float is equal to 10.5 or something like that, or 10.6, I mistyped. Then we can, if we print it out, we're going to get 10.6. However, we can also print int my float. So when I print my float, I print out 10.6. If I use the function int on my float, then I get 10. So you can also store that to a variable. So I want to say my float to int is equal to int 10, my float. And instead of doing the function here, I'll do my float to int and run it. So I've transformed my floating point number into an integer using the built-in function int, or int. That will come in handy a lot if you're trying to use numbers for list indexing. So this concludes our first video of text-based Python. I know it was a lot of information, but we covered two very important things: using strings and using numbers. In the next video, we're going to look at how to implement if statements and comparison operators.